Assalamualaikum warahmatullahi wabarakatuh, and very good afternoon to Sir Muhammad Aldi bin Ayub. So today we are going to explain about that 5 voltage regulator. So I am Muhammad Ahmad Fadlan bin Ahmad Fauzi. We'll explain about part 1, which is an op-amp series voltage regulator. So generally, the voltage regulator is a circuit which keeps the output voltage constant under all operating conditions. The voltage regulator is needed to keep voltage within the prescribed range that can be tolerated by the electrical equipment using that voltage. So for this type of voltage regulator, uh, op-amp and transistor plays a big role here, as uh, we know that operational amplifier here act as error detector, and transistor act as control element. So the op-amp is used as a comparator. It compares the part of the output voltage obtained from potential divider circuit as a feedback with the reference voltage generated by the Zener diode. The output of the op-amp drives the series pass transistor Q. If there is any change in output voltage, the control signal from op-amp control the conduction of the transistor Q. Thus, the output voltage is maintained at a constant level. So, from the circuit, here are what I have done, and here are the value of every uh, voltage input with increment of 0.5 volt. So that's all. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Akib bin Halim. So I will explain about part 2, which is full bridge voltage regulator circuit. So for part 2, the total circuit we have 4 total circuit. So the first circuit shows us the circuit with full rectifier, full bridge rectifier. So this circuit shows us that from the oscilloscope we can see the wave we have a full wave rectified voltage, which is all in the positive value, positive voltage. And then after that we have a full bridge rectifier with filter. So what this circuit do is it will reduce the peak to peak pulses to small ripple voltage, as you can see from the oscilloscope, the wave. And then after that we have a full bridge rectifier with filter and voltage regulator. So what this circuit do is it will provide much less ripple, and the DC value will remain the same, even if the input DC voltage varies. So this is with the capacity C1 with 10 micro farad. So the last circuit we have filter with 220 microfarad. So the circuit shows us we have much less ripple voltage, and the wave is much smoother than the previous circuit that have 10 microfarad. So in conclusion, the full bridge rectifier with voltage filter and voltage regulator that have 220 microfarad is have much less ripple and more smoother wave. So that's all from part 2.
Okay, Assalamualaikum. My name is Muhammad Ashraf. For my part 3 is adjustable voltage regulator circuit. So for my part is this circuit, we only have to adjust the potentiometer to get the value given. So as I construct the adjustable voltage regulator circuit, where the supply of 5 volt threshold is needed for the IC to be active, and we can monitor that from VR2 value, where VR2 is okay. It's like when we set up the from 5 volt to 7 volt. As we can see, the voltage will started to drop when we obtain the output voltage above 7 volts. So as we can see, VR2 from 5 volt to 7.56 volts, so it started to drop up. So because of the because of the IC and the potentiometer adjustable. So this is for the circuit that I have done for my multi-sims. As the result that we achieve it. So okay, for the part of discussions that we have do it, so what we understand, so the voltage regulator is a circuit where which we keeps the output voltage constant under all operating condition. So at the same times, voltage regulator is needed to be keep voltage where within the prescribed range that can be tolerated by the electrical equipment using that voltage. And as we can see, part 1, what we call is a series regulator circuit using OP amplifier. So as we know, OP amplifier is used as a comparator and is compares the part of the output voltage has been using for the potential divider circuit as a feedback. So this one is like reference voltage generated by the Zener diode. So the output of the OP is will series passed by transistor Q. So as we can conclude all the lab where this part of 3 we achieve and obtain the result that we have been given. So thank you, this is for us.